Welcome to the week 5 walkthrough. We're going to talk about the 5 problems in this week's homework. In this one, they get progressively more complicated, but when you get to your exam, they're not going to have as many steps in them. This week, we're looking at momentum. Momentum P, we use P for momentum, is just mass times velocity. So momentum is going to have units of kilograms, meters per second, because mass is kilograms, velocity is meters per second. One of the reasons we really look at momentum is that momentum is conserved in collisions. So no matter what happens, the momentum before something happens and the momentum after it happens is the same. Um, and that's expressed by this equation P1 plus P2 equals P1 prime plus P2 prime. The prime indicates that something has happened between the beginning of this equation and the end of this equation. Another way to think about writing this is M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. Right? So that's a different way of writing this same equation. We're just taking the MV and putting it in for each one of these. The other concept we're introducing in this chapter is impulse. Now, impulse is when you buy a pair of tennis shoes because they look really cute or something like that. But impulse is also a change in momentum, right? And we use the symbol J for the impulse. And it has the same units as momentum, kilograms, meters per second. So the impulse for object 1 is P1 prime minus P1. Impulse for object 2 in a collision is P2 prime minus P2. So let's look at these problems. The first one is straightforward. We have a mass, we have a velocity. We're asked for the momentum. We just go back up to the definition. Momentum is mass times velocity, and that's all we need. And the next one, we have a car headed east and a car headed west, right? So the car headed west, and we say, what's the total momentum in the eastern direction? And since the one is headed west, that we actually have to subtract out its momentum, right? So this one we would do is the total momentum P is equal to M1 V1 minus M2 V2, and the minus is because the second car is headed west instead of east. In part 3, or question 3, we're adding on a little bit to the problem in question 2. So now we have one headed north, one headed south. They collide and stick together. What's the total velocity after the collision, right? So again, we've got M1 V1 minus, because they're heading in opposite direction, M2 V2, where V2 is the one headed south, right? Oh, V2, make that a 2. Now they stick together. What does that mean? That means after the collision they are together, right? And since they're together, they're going just a single velocity. So we're trying to solve for their velocity after the collision. So M1 V1 minus M2 V2 equals the sum of their masses, because they're now stuck together, times the velocity they're now moving at. Question 4 takes the same concept one step further. All right, so we're where we were at the end of the last problem, M1 V1 minus M2 V2. The cars are stuck together, M1 plus M2 onto the final velocity, right? Well, then the question is, what is the impulse on the car headed south? Well, for the car headed south, what's its final momentum? All right, M2V. All right, we've got its final momentum, M2 times V, and we subtract out Now, this has a minus sign because it was headed the other way, so we end up adding m2 v2. Right, and there you go, the momentum, the impulse on the car headed south. So it has its momentum afterwards. We subtract out, but that minus sign is there. We subtract out its momentum before to get the change in momentum for this car. Problem 5. We've got a car that has a velocity of 14.2 meters per second. It collides with another car. We don't know the velocity on the second car. We know their masses, but we do know that after they collide, everything comes to a stop. Right? Everything comes to a stop. Well, momentum is conserved. So momentum before the collision, m1, v1, they're headed in opposite directions. So again, we've got a minus sign there. m2, 2, v2, right, equals what? Well, what's their momentum afterwards? Momentum is a conserved quantity. Momentum is the same before and after. They're sitting still afterwards, so their momentum afterwards is zero. Right? And so in the last problem, the total momentum before the collision must equal to zero, which means the only thing we know m1, we know v1, and we know m2. The only thing we need to figure out then is v2, and that's our only unknown. And that's it for the week 5 walkthrough. Hopefully this helps.